Okay, today we're going to be working on solving inequalities. Let's go over this first page of notes here really quickly. If you haven't already, go ahead and put your name on both sheets of paper. And just so you know, this is lesson 4.3. McNabb. This is my video copy. There you go. Okay. So, first off, let's talk about what is an inequality. Go ahead and zoom in for you guys here. An inequality is two expressions with an inequality sign in between them. Now, it's similar to an expression or an equation. We're used to equations that actually have equal signs in between them in the middle. An inequality is similar in structure. It looks similar, except it's going to have an inequality sign. And those look like, those are our alligators. So there are less than or equal to, greater than or equal to, or greater than. An example of some examples of inequalities you might see 7 is greater than 3. You might see x is less than or equal to 2. Or you might see 2x is greater than, or less than, less than 6. Those are all examples of inequalities. Okay, solutions. We've actually been finding solutions. We just haven't really been calling them that. A solution is anything that you would call an answer to an equation or an inequality. So it's the answer. And what it is it's a value that makes an equation or an inequality true. So for equations, there is only one solution. But so there's only one number that can make an equation true. There are many numbers, many values that can make an inequality true. And to think about that for a minute, let's think about our example from up here. 2x is less than 6. Well, let's think about the equation, EQ. Let's think about the equation 2x equals 6. So that's an equation because it has an equal sign. If I divide that out, divide both sides by 2, I learn that x equals 3. That means that for 2x equals 6, the only number that I can put in for x, the only thing that x can equal is 3 for this to be a true statement. So if I put 2, and instead of x I put 3 equals 6, 6 equals 6. That is a true statement. 6 does in fact equal 6. I know that's new information for you, but it's true. 6 equals 6. So for an equation, there is only one number that's ever going to work for that, that's ever going to make sure that that's true. There's no other number we can put in for x that's going to make a true statement. For inequalities, however, let's say we have 2x is less than 6. Let's go ahead and do our same rules apply, y'all. So we can divide both sides by 2. X less than 6 divided by 2 is 3. So we come up with x is less than 3. Okay, this is different. X equals 3. X is less than 3. So let's think of a number that's less than 3. Let's try 1. So what if we did 2, and we can put them into 2x is less than 6. So let's do 2, 1 is less than 6. Well, 2 times 1 is 2 is less than 6. 2 is less than 6. That checks out. That is a true statement. But let's think like other numbers. What if we had -5? Well, let's try 2. -5 is less than 6. 2 times -5 is -10. Less than 6. -10 is also less than 6. So we've got some different answers here. When you're working with a inequality, it can be multiple answers, because what this means is x is anything that is less than 3. It could be -1 million, and that's less than 3, so that would make this true. Okay? So when we're looking at inequalities, there are many values that could make it true. Looking at the example that we just had, if we have 2x is less than 6, and we simplify that down to x is less than 3, we know that x could equal, let's see some of our examples we had, x could equal 1, it could equal -5, I think we said it could equal -100, and I'm just going to do ... because it actually goes on and on and on and on. There is actually no way we could sit down and write out all of the things that x could equal. That's why we write it this way. X is less than 3. So it's just saying x is anything less than 3. Okay, let's do a quick review of our signs here. If you ever need these will be here for you to double check back on. This symbol right here means greater than or equal to. We did get a little bit of bad news from our copier. It decided to punch a hole right on our less than sign. So less than looks like that, and less than or equal to looks like that. The way I remember it is that I think about them as crocodile mouths, and crocodiles want to eat the bigger meal. So we'll go more into those. Well, oh, the other thing that I try to remember too is that we have the difference between greater than and greater than or equal to. These are different. The way that I remember which sign involves or equal to is I look for, well, this one looks like an alligator ate half of an equal sign. So this one is greater than or equal to, and then this one is just plain old greater than. We're going to skip this section for just a moment. We'll be back. Let's talk about this. So here we have two different statements. We have x is greater than 4, and we also have 4 is less than x. Okay, these actually, guys, mean the same exact thing. So you can flip it. You can flip your, you can just flip the sides, but you have to make sure that the alligator is still eating the same thing. So here, my alligator is eating the x. That means the x is bigger. So if I want to flip it and I want my 4 to go first, that's fine. I just have to make sure that my alligator is still eating my x. So my alligator has to flip too. So these say the same thing. Okay, let's graph a little bit, shall we? Okay, so we have, let's see. Right here, this says x is greater than -3. I need to graph it on this number line. I need to graph what my solutions are. So x is greater than -3. I know that I have a critical number here that is -3. -3 is going to be very much involved. I chose to do an open circle because my alligator is just an alligator. So it's just a greater than or a less than. There's not an equal to involved. So if it's just the alligator, not an equal sign, it's going to be an open circle. Now, here's a little trick. As long as my variable is like like Beyonce's boxes, to the left, everything you own in a box to the left. As long as my variable is to the left, this inequality sign is going to tell me exactly which way my arrow is going to point. So if you look right here, I can see that my arrow is going to point to the right. So that means that all of these numbers continuing forever and ever and ever and ever are solutions. They make this statement true. So I could say that 0 is definitely greater than -3. Check. I could say that 6 is greater than -3. Yep. I could say that 10 is greater than -3. I could say that 135,986 is greater than -3. Okay? Let's talk about some things that are not solutions. Looking at our chart and thinking about it. -6 is not greater than -3. I'm so sorry. -6 is not greater than -3. -9 is not greater than -3. Let's think about -3 itself, though. Is -3 a solution for this? Can x be -3 and we can have a true statement? Well, let's think about it. What if I said -3 is greater than -3? Can -3 be more than -3? I like to think about it like a soccer game where if both teams have 3 points, did either team win? No, because one of the team has to have a greater number of points. So you can't be the same and be greater than. So when we have just our greater than or just our less than, so when we've got these open circles, this critical number is not a solution. Okay. We're going to go ahead and move on to the next one. X is greater than or equal to, oh, it's a little bit different, -3. Again, my -3 is a critical number here. Now, though, I have a little bit different. I have my alligator with the equal sign under it, so I can fill this in. Okay. Again, my variable is to the left, everything you own in a box to the left. And so my arrow is going to show me which way, or my sign is going to show me which way my arrow goes. Okay, so these look relatively similar, don't they? They both start at -3 and they both point in this direction. However, this one has the open circle, this one has the closed circle. This one is just greater than, this one is greater than, or equal to. So that makes a big difference because -3 is not greater than, -3 is not greater than -3, but it is equal to. So that means that now -3 is a solution. 10 is greater than or equal to -3. 5 is greater than or equal to -3. -10 is not greater than or equal to -3. And -7, also not a solution. Okay, let's look at x is less than -3. Well, again, we know that -3 is going to be our critical number for these examples. So we have -3. I know I'm going to have an open circle because I have my -3, or my less than, sorry. So I'm going to have an open circle. My variable is to the left. So that means my inequality tells me which way my arrow is going to point. It's going to point this way. Okay? So now we're going in a different direction than we've been going. So now let's think about this. X is less than -3. Is 8 less than -3? Nope, sure isn't. Is 0 less than negative 3? No, sir. Is negative 6 less than negative 3? You betcha. So that is a possible solution because it makes this true. Is negative 9 less than negative 3? It sure is. So that's a possible solution. Let's think about negative 3. Is negative 3 less than negative 3? Well, just like up here, negative 3 is not greater than negative 3. It is also not less than negative 3. So negative 3 is not less than negative 3. It is not a solution. It does not make this true. Okay? So if we've got the open circle, our critical number is not part of the solution. If we've got the closed circle, our critical number seems to be part of the solution. Let's think about it. Let's think about the next one and see what we come up with. Okay, last but not least, we have x is less than or equal to negative 3. So we know last time that our critical number is going to be negative 3. We have that alligator that's eating part of the equal sign. So that means I have a full circle. Okay. My variable is to the left. So that means that my arrow tells, or my sign tells me which way my arrow goes. It goes this way. So now let's think about it. Negative 8 is less than or equal to negative 3. That's a solution. Negative 5 is less than or equal to negative 3. It's also a solution. Not negative 3. 3, is that less than or equal to negative 3? Nope. 7, is that less than or equal to negative 3? Nope again. Okay. So now for the last time, let's think about actually negative 3. Is negative 3 less than or equal to negative 3? A lot of times students will want to tell me equal to. That's not what I'm asking. I'm asking a yes or no question. Is it less than or equal to negative 3? Does it fit into this category? So I'm looking for a yes or a no. So is it a solution? Is it less than or equal to negative 3? I think we figured out last time that with our filled in circles, because it includes that or equal to, negative 3 certainly is equal to negative 3. So that is a solution. Okay. Let's go ahead and do some problems, shall we? Okay. Which color do I have? Let's do some examples. Which color am I on there? Blue. Okay. So, example 1. So these all say solve for x, graph your answer on the number line. We are not going to graph our answer on all these because I kind of goofed up just a little bit on the numbering, and so we're only going to graph the first one. So solve for x, graph your answer on the number line. So remember, this is the same as if we were solving an equation. I'm trying to get x by itself, and that's it. Okay, following my same rules, my same procedures, everything I know how to do. So I have x on this side. I drew my gate through my inequality sign. We'll talk about the inequality sign here in a minute. But I know right away that to get my x by itself, I need to subtract 4 from both sides. Okay. That brings my x down. My 4 minus 4 cancels out. We love that part. X, my inequality sign stays exactly the same. Stays going the same direction. And then 14 minus 4 is 10. So I know that x is greater than 10. Okay. Let's try graphing it. I know my critical number is 10. It's not equal to, so this stays an open circle. And my arrow, because my variable's on the left, my arrow tells me which way my sign tells me which way my arrow goes, so it's going to go this way. So there you go. And we can think about that a little bit, guys. With 0, let's say I had 0 and I put it into x plus 4. So x plus 4 greater than 14. What if I put 0 in for x? 0 plus 4 greater than 14. Well, 0 plus 4 is 4 greater than 14. Is that a solution? No, sir. Let's try to think of a number bigger than 10 we could try. I want to try, let's try 20. So let's try x plus 4 is greater than 14. 20 plus 4 is greater than 14. 24 is greater than 14. That is a true statement. 24 is greater than 14. So that actually checks out. Okay? And remember here, 10 is not going to make it true. 10 is not a solution. I'm going to put like way out here. I'm going to put 20 and do a check mark. Okay? Okay, and like I said, I did goof up the number lines on all of these, so that's the only one we're actually going to graph. Green is up next. Okay, now let's look at this next one. We have negative x divided by 7 is greater than 14. Well, let's bring our gate down. So I know that I want to get x by itself. Well, and since x is being divided by something, I know I'm going to undo that with multiplication. I am going to multiply something. And I'm going to multiply not just by 7, but that would leave my negative here. I'm going to go ahead and multiply by negative 7. So I'm going to multiply both sides by negative 7. Okay? Here comes the one difference when we're doing inequalities versus equations. The one difference. Are you ready for it? When you multiply or divide by a negative number, I'm just doing a negative there so you can see it, by a negative, you flip your inequality sign. So, because we are multiplying both sides by a negative number, negative 7, we are going to go ahead, so these cancel out, our x comes down. But now, instead of keeping it as greater than, because we multiplied by a negative, we have to follow our rule here and flip our sign. So instead of greater than, it's now going to be less than negative. Oh no, let's do the old warthog math. So 14 times 7, 7 times 4 is 8 to 9. Ooh, it's 98. Look at that. So this means that x has to be less than negative 98 to make that statement true. Y'all want to test it out? Because we're not going to graph it, remember? I goofed. We're not going to graph it. But let's do some tests here. See if we can figure out. So we have negative x over 7 greater than 14. Okay. Let's try so if we were to go this way on the number line from negative 98, we'd actually hit negative 100. But we need something that's easily divisible by 7. Let's just do negative 700. That sounds good. Okay, so let's do if x equaled negative 700. Let's try it. So we have negative 700. Do we see why our parentheses are so important when we're substituting stuff in? You see? Okay. Divided by 7 is greater than 14. Let's see what we do here. Well, I have a negative, so that turns into a positive. So now I have 700 divided by 7 is greater than 14. 700 divided by 7 is 100 is greater than 14. So, is this a true statement? Absolutely. So when I put negative 700 in there, which is less than, it's like way far out this way on a number line from negative 98, I get a true statement, don't I? Okay, so that works out. Now, let's try to find a non-example just to prove it. So what if we tried 0? Because I know that if I'm looking at negative 98 on a number line, and I go this way instead of that way, and I go this way instead of that way, I'm eventually going to get to 0. 0 is a fun number to test with. So let's do 0. So if x equaled 0, so if I had negative x divided by 7 is greater than 14, and if I said x equals 0, so I would have negative 0 divided by 7 is greater than 14. Okay, I know that 0 divided by anything is always going to be 0. There's no positive or negative 0, it's just 0. Is greater than 14. Is that a true statement? That is not a true statement. So that makes sense that when I try something that is bigger than negative 98, which is 0, that does not work out. But when I try something that is further this way on the number line than negative 98, it does work out. So negative 700, possible solution. 0, not a solution. And they fit into our inequality thing. Okay, 2 more. Whew. Let's see. Okay. We got this, y'all. Okay. So we have 9x minus 43 is greater than or equal to negative 7. Again, we are not messing around with this number line that I totally messed up. Okay. We're going to add 43 to both sides. Okay. If you don't have Desmos on hand, that's fine. I'll be your Desmos. So we have 9x. Our sign does not change because we just added 43. That's not multiplying by a negative. So our sign stays the same. And then negative 7 plus 43 is actually 36. And then we divide both sides by 9. Gives us x is greater than or equal to, 36 divided by 9. 36 divided by 9, I'll be your Desmos, 4. Oh, we probably could have graphed that one. Oh well, we won't. Okay, last but not least, let's do just a teeny tiny word problem. This is a very realistic word problem. My bank account requires a minimum balance of $100. Use X to represent the possible amount of money I could have in my account. Write an inequality to represent this situation, and then graph your solution on a graph. We are not graphing. Ooh, she messed it all up. Okay. So we are just going to write the inequality. So I know that X is the amount of money, right? And I know that 100 is my critical number. Okay? Minimum balance. Minimum means it's like the bottom. It's like the minimum purchase or something. It's always the bottom, the lowest you can go. The minimum age to vote is 18, right? So the minimum is the lowest. Okay? So what this is telling me is that I have to have a minimum balance of $100. That means the lowest amount of money I can have in my bank account is $100. So does that mean that I have to have, is this going to be, does my X need to be greater than or less than 100? Like, can I have $98? No. So I know that I can have $150, and that's good. So I know that my crocodile wants to eat my X. But then let's also think, because we have an option here. We could put an equal sign or we could not. So it says a minimum balance of $100. I can have, that sounds to me like I can have $100. Just like I was talking about, the minimum age to vote is 18. So $100, I could have $100. So could X also be equal to 100? Darn sure it could. X has to be greater than or equal to 100. Okay, there you go, guys. Best of luck. Hope you enjoyed it.